Okay, in this video we'll be looking at some slightly more complicated logarithmic inequalities, and we'll start off with this one. A shout out to one of my students for sending me this one to try to solve. Alright, so what we have here, we've got 2 log 2x plus log of 3x minus 1 all less than log 5 plus log x. Right, so first thing we want to do is we want to get a single log on both sides if we can, or a single log on one side and a number on the other, doesn't really matter. We're going to go with the route of just combining these logs on this side and combining these logs on this side. So we see everything already has the same base, everything is already a log. Right, so now we can just apply our basic rules of condensing and expanding logarithms to see what we do. So first, we're going to take the coefficient in front, the 2, and move it to the top. So turn a multiplication into a exponentiation. Right, so we're going to start off by saying this first term becomes log of 2x squared. Right, so we took the 2 from the front to the exponent, plus log, here we can do nothing, so we just keep it as 3x minus 1. Less than, and here we can do nothing of that sort to start with. Now in the next step we'll be combining these. So on the left we've got log of something plus log of something, so that'll turn into log of those two things multiplied together. So we're going to have 2x squared multiplied by 3x minus 1. Alright. And that's going to be less than, this side will combine these two logs, that'll be log of the two things multiplied together, 5x, 5 times x. Okay, and now that we've got log of something is less than log of something, single log on both sides with the same base, base 10 both of them, now we can sort of ignore, in inverted commas, the logs. Okay, so we can just say the left hand side, 2x squared times 3x minus 1, that is less than 5x. Alright, so let's multiply this out. So squaring 2x we get 4x squared, and we're going to multiply that by 3x minus 1. That's still all less than 5x. So we're doing all the steps. We could skip a few if we like, but we're going to, for completeness sake, do everything. So 4x squared times 3x, that gives us 12x cubed, and 4x squared times negative 1, that's negative 4x squared. Alright, and we've got the 5x this side. Now we're going to take everything to one side, so we keep everything on the left, 12x cubed minus 4x squared, and then minus 5x less than 0, and now we can factorize. So here we can take out a common factor of x, and we're left with x squared, 12x squared. Let me just erase that. Okay, so take out an x from here, we're left with 12x squared minus 4x minus 5 less than 0. Okay, x, and now this is a quadratic trinomial that we can factorize further. So we'll have our two brackets, still less than 0, and in these two brackets, if we factorize this, I'm not going to go over all the factorizing again, but what we will get is 2x plus 1 in this bracket, and we'll get a 6x minus 5 in this one. And we'll see that works out. 2x times 6x is 12x squared, and we've got, that gives us negative 10x plus 6x, which is negative 4x, and 1 times negative 5 is negative 5. So there we have it. So now our critical values, let's change color for this one. Okay, so our critical values, let me move down a little bit here. Right, critical values, crit vals. So if this was an equation, what we would have. So we'd have x equals 0, or x equals negative half from this one if we set that equal to 0, or if we set this equal to 0, we'll have x equals 5 over 6. Okay, so what do our critical values tell us? Well, they tell us what the graph would look like. These are x-intercepts on the graph. So our graph, let's draw it. Okay, y-axis, x-axis, and we see we've got a negative half. There's one intercept. We've got 0. There's another intercept. And we've got 5 over 6. So there's another intercept. And now we see this. What is this? This is our graph, right? So that is a cubic function. So a cubic function we know either looks like, if it's positive, it looks like that. If it's so that's for a positive one. If it's negative, it looks like that. So we have a positive graph that the 12 is positive, the value in front of the highest exponent. So that means we're going to have a graph looking like that. So here we go. Let's draw that in. I'm going to draw that in another color again. Okay, so it's going to look something like that. And the nice thing about higher level math is we don't have to do accurate drawings. We can just sketch. Alright, so let's just fill in these values. So that's going to be negative half. That is 0. And this is 5 over 6. Okay. And we're told, where's this graph? After we factorize, where is it less than 0? So less than 0 means below the x-axis. Right, so it's everything to this side of the graph. So everything less than negative half. So let's write that down slow. So x is less than negative half. And this is the other spot, this part here. So that is between 0 and 5 over 6. So that means x is between 0 and 5 over 6. So here we have our two constraints so far. But we're not done. Because remember, we're working with a logarithmic inequality. So we need to know that all these values also have to be greater than 0, because we can't have log of a negative number. Right? So some more constraints would be that 2x has to be greater than 0. Divide both sides by 2, that gives us x must be greater than 0. There's another constraint. Then we have this part. So we know that 3x minus 1 must be greater than 0. And we're going to solve this one quickly. And divide by 3, so x must be greater than 1 over 3. So there's another one. And finally this one here, x must be greater than 0. We've already solved that in essence. Okay, so here we see we've got all our constraints, right? So let's just zoom out a little bit. So all our constraints here. Now let's do that on a number line. So we've got, here's our number line, and we're going to fill in our values. So our values, the smallest one of all of these is negative a half. So we're going to put negative half. Then we've got 0. Then we've got 5 over 6 and 1 over 3. So we've got 1 over 3. And we've got 5 over 6. Okay, so that covers all the values we need. So let's draw them in. So we know x has to be less than negative half. Right, so less than negative half. Or between 0 and 5 over 6. So between 0 and 5 over 6. And we've also got that x must be greater than 0. So greater than 0. Well, that's an ugly line. And also x has to be greater than a third. So greater than a third. Alright, so where's the only place where all these constraints hold? The only place where all of them hold is right here. In between those two places. So that'll be our final answer, this little part here. right? And what is that? That is between 1 over 3 and 5 over 6. So there we go. So that was a really nice inequality problem that gave us a cubic function to draw. Right? That's not very common in our syllabus. So that's a good problem. I like that one. Now let's look at one of the other ones, one of the normal ones we usually get, quadratic. Alright, so let me just zoom back in a little bit here. I don't know where the zoom button is. Let's... What's that? What's that? No, that doesn't do anything. I'm trying to find how to fill the screen so I can draw again. That doesn't work. Oh man. No. What am I doing? Ah, okay, I see. There we go. Filled the screen. Right. Sorry for that delay. Okay, let's tackle this problem. So this one, we've got 5 minus log of x plus 1 with the base 2 is smaller than log of x minus 3, also with a base 2. So first thing we want to do is we want to convert this also into a base 2. Right, so we know that anything, so let's just start doing that. So log with a base 2, if we make this a 2, now we know this is 1. But we want 5, so let's just say we multiply that whole thing by 5. That's usually the easiest way to convert a number into a specific base. So you just do log of whatever that base is with itself. So log, if it's base 2, you put 2. If it's log with a base 7, you put a 7. And that gives us 1. And then we can put whatever this number is just in front of that. Right, let's continue. So log base 2 of x plus 1 less than log base 2 of x minus 3. Right, now we can use our laws of logs to simplify this. So first we can take the 5 to become an exponent there. So log base 2 of 2 to the power of 5 minus, and let's just rewrite these ones, sorry for the ugly handwriting, log base 2 of x minus 3. Alright, so this is 32, 2 to the power of 5. Now we want to combine. We've got the same bases everywhere, so that's fantastic. Now we want to combine or condense this side. So we're going to have log base 2, and then we're going to have, we've got something minus something, so that'll be a division. So 2 to the power of 5, 32 over x plus 1. And on the other side, we've got log base 2 of x minus 3. Okay, and now since we've got a single log on both sides with the same base, we can sort of ignore the logs. So all we're left with is this part. 32 over x plus 1 is less than x minus 3. Right, so let's multiply both sides by x plus 1 to get rid of the fraction. That'll give us 32 is less than x minus 3 times x plus 1. And that'll give us 32 is less than, if we multiply this out, we get x squared minus 3x plus x is minus 2x and minus 3. Right, so one more line here and then we'll zoom out a little bit. So 0 is less than x squared minus 2x, and then minus 3 minus 32 gives us minus 35. Okay, now let's scroll down a little bit so we can factorize this. So let's keep 0 is less than, and this one, quadratic trinomial, we can factorize this into x minus 7 and x plus 5. Now we go back to our critical values. So our critical values are if we were solving this with an equal sign. Right, so if this bracket equals 0, then x must be 7, or if this bracket equals 0, then x must be negative 5. Right, and what do the critical values help us with? Well, they help us on our graph to identify exactly what we're looking for. And we'll have our values either negative 5 or 7. And this is a parabola, smiley face parabola, so there we go. And we want to know, where is this parabola above the x-axis, sorry. Where is this greater than 0? So where is greater than 0? All the way left of 5. So that whole area is above the x-axis, and this whole area, let me just draw that on. This whole area is also above the x-axis. So we know that x must be to the left of 5, which means less than 5, or x must be to the right of 7, which is greater than 7. So there we have two constraints. Now we need some more constraints, or we have some more constraints. We know that this part, we can only have logs of positive numbers, right? So this part, x plus 1 must be greater than 0, which means that x must be greater than negative 1, another constraint. And this also must be greater than 0. So x minus 3 greater than 0, which means that x must be greater than 3. So there we have another constraint. Now, let's see. Okay, let's zoom out a little bit, just so we can see all the constraints. And let's draw a number line. Right, so our number line, right over here. And what values do we have? Well, we've got negative 5, 7, negative 1, and 3. Smallest one is negative 5. So there's negative 5. Then we've got negative 1. And then we've got 3. And we've got 7. Okay, so x must be less than negative 5. So less than negative 5. X must be greater than 7. And we've got x must be greater than negative 1. And we've got x must be greater than 3. Okay, so where are all these constraints true? Only in one spot, and that is here. So everything to the right of this line is where it is all true. All of them are true right over there. And what is that part? That is x greater than 7. Right, so that is what gives us our answer. Okay, thank you for tuning in for this one, and please let me know if you have any other questions. It's always great to get some challenging questions and to solve them.